We have heard from two steel manufacturers. Let me now come to straight to you, Shubhadeep, because from solutions side, you have been working on the electrification, automation, maybe more from the hardware side.
Yeah.
But with your any ecosystem players with whom you may be developing solutions in that regard, would you like to share that what kind of solutions seem to be more the low-hanging fruits in terms of going to work to in this decarbonization journey for Indian steel?
Yeah, thanks, Vidyut. I mean, the forum knows India needs the BF-BOF route, and since morning, Mr. Gaurav Verma from M. Dastu said there is no one magic wand that can be applied to have the decarbonized steel at one go. So I'll just talk of one of the possible ways that we are trying to innovate at Siemens Energy, through which we can at least achieve a bit of it. This is a versatile technology, not only for the BF-BOF route, but it can be applied to other fields as well, like the electric arc furnaces and the other routes to steel, as well as in cement and oil and gas and other areas. So here, very specifically, I'm going to talk about the electrification possibilities of heat that is used in the entire process. For example, starting from the coke oven to the sintering process, the hot air injection into to the blast furnace, and also the processes for secondary steel making, where wherever fossil fuel is combusted to produce heat for the process. That is where we specifically would target with our technology, which I'll brief you about in a while, for the electrification. So the first step would be to try to supplement the fossil fuel firing with the electrification, and in the long term, complete replacement of the fossil fuel firing through this electrification process. And in the whole process, the basic or the main intention is absolutely not to touch the metallurgy of the process. So what we are trying to develop is a turbo machine, which we call as a turbo heater. Based on our strength is developing gas turbines and steam turbines and compressors. So it's based on the same principles. It's a turbo machine through which we accelerate a fluid to supersonic velocities and then decelerate it, which creates a certain shock wave. And this shock wave, when it's decelerated, creates enormous amount of heat. And since this is a turbo machine, we know like turbo machine can be as small as a pump to as big as a turbojet engine or big nuclear turbines or gas turbines. This turbo machine is scalable. The basic fundamental principle of a turbo machine is that it's scalable. So this turbo machine can create temperatures up to 1000 degrees centigrade in the first go. We are targeting even higher. And it can produce heat at 100 megawatt thermal or even more. So that's the scale that we are trying to talk of. Through this turbo machine, this is a turbo heater, when we try to apply this, all the fossil fuel fired heating processes can really be replaced through this electrification. And that would essentially reduce a lot of carbon footprint in the entire process. And as I said, this is a versatile concept. It's a generic concept, not only for steel making. It can be applied for cement. It can be applied anywhere else as well. In the entire process, what it would also do is it can also reduce the footprint and the size requirement for CCUS plants, because CCUS, as we know, today it requires a significant capex and opex as well as real estate requirement. So if we upfront reduce the carbon dioxide generation through fossil fuel burning just for the heating processes, it can also at the end reduce the size of CCUS. So that's an add-on effect. So this is what I would like to highlight here.
Yeah, thanks, Subhadeep. Just a clarification, is it more at a pilot stage that is ongoing, or is it at a commercial scale?
Okay, so at Siemens Energy, we have, so this is an in-house development. We have tested this as a demonstrator at 1.8 megawatts at our own labs. The tests do well. We are now implementing pilot plants at various sites globally. And we would like to, also investigate the possibility of pilots for steel making in India. Because as I said, I mean, Siemens Energy is a company which is more than 100 years old in the country, and we have a big manufacturing footprint here. So we make products for India in India, and that would also solve the, the Make in India requirements that come in along with it.
Thank you, Subhadeep.